Hey Math All Stars, it's Dr. Conklin. Shout out to one of Miss Vala's students who wanted Real Love. Pretty good song. So we're going to start on page 4 today, and we're looking at proofs. Yay! So, a couple things to highlight. Every time we have a proof, we're usually going to have a few things. A picture, which you notice I already started to mark up. Make sure you mark up your pictures. We have a given statement and a proof statement. So, when we are writing a proof in geometry or in algebra, like we learned yesterday's video, we're going to have a statement column and a reason column. And we always start off our proof by writing the first given. You see I put it here. And our reason is that it's given. So let's talk about this, and I want to just take this picture and blow it up a little bit. We want to prove that 3 is congruent to 5. How are we going to do that? Well, you can see I've already sort of laid this out. Oops, this should be a 3, guys. Sorry, you can change that in your notes. As I look here at the picture, we're told that these two lines are parallel. And when we have parallel lines cut by a transversal, remember this is our transversal, it's a different color, a lot of neat things happen. So let's look at 3 and 5. And I circled angle 7 because it's sort of going to help us to get there. Angle 7 is going to act as sort of like a middleman. By that I mean it's going to help us connect angle 3 to angle 5. So first, what is the relationship between angle 7 and angle 5? They're across from each other, which means they're also congruent. And why are they congruent, guys? Angle 5 is congruent to angle 7. That's our statement, because we know all vertical angles are congruent angles. Okay? Now, let's look at the other pair of angles that I've sort of highlighted here for us. Let's look at 7 and see how it connects to 3. So thinking back in our unit, what is the relationship between 3 and 7? They're on the same side. Let me get rid of a couple of these colors here. I want you guys to know I'll go crazy with the colors. So if I make my little T here, do you guys see here? Here's angle 2. If I move this down, this is in the same spot. If we're looking at angle 3 though, here's angle 3. If I move that down, do you see how that matches up with 7? So those are corresponding angles. So angle 3 is congruent to angle 7. And the reason for that is parallel lines imply that we have corresponding angles congruent. Now you could totally write that whole sentence out if you'd like to. I sort of just like writing it a little bit I call it like a short form, because then it's not as stressful, and it's a lot easier just to look at the short form rather than the long form. Okay, so how are we going to finally prove this statement? Right, if we look here, does everyone see here we have angle 7 and angle 7? Well, yesterday we talked about something called transitive property, which you can already see I put in. But basically, angle 5 is congruent to angle 7, and angle 7 is congruent to angle 3. So let's say that I told you guys the measure of angle 7 is 120 degrees. Well, let's plug this in. If this is 120 and this is 120, what does that mean about 5 and about 3? Well, those angles also have to be what? 120, okay? So, since we know that angle 7 is congruent to both, let me go back to the picture. Since 7 is congruent to 3 and 7 is congruent to 5, it means that 3 and 5 have to be congruent to each other. Okay, so if we look at the next example, we're sort of going to do the same thing again, but now I'm going to have you guys fill this in a little bit more. Here's our given. Remember, we always start with that. So line L is parallel. Remember, that symbol means parallel to line M, and that's our given. We want to prove that angle 1 is congruent to angle 7. So we're going to work backwards. Angle 1, angle 7. So what I'm going to do is look for an angle that's sort of in common between them. So let me just take a look. There's actually a lot of angles here. If I look at angle 1, if I start with that, I see that angle 3 is vertical from it. Now, what's the relationship between angle 3 and angle 7? Those are, again, What kind of angles, guys? Corresponding. So we're going to do angle 1 is congruent to angle 3. Sorry, that's not a good color. Angle 1 is congruent to angle 3. Now our reason for that is vertical angles. Angles tell us we have congruent angles. Again, you could write the full definition out if you want, but this is a little bit of a shortcut. Now, we're going to use angles to connect 1 and 7. We're going to use sort of 3 as sort of our middleman. So now we're going to say angle 3 is congruent to angle 7. And the reason for that is these angles are corresponding. Parallel lines tell us corresponding angles are congruent. Okay, so again, we're writing our statement, and then we're writing our reason to go with it. And last but not least, if we look here, do you guys see how 3 is in between both? Which means, another way I sort of like to write it is this. Angle 1 is congruent to angle 3. Angle 3 is congruent to angle 7. You sort of like swipe these. You see how these overlap? Which means 1 and 7 have to be congruent. So what property is that? Again, we learned it last time. Transitive property. Okay, so I think we're going to try maybe one more example before we go through and let you guys try homework. We're going to skip the example on page 5. We're going to look down at this example, and I'm sorry the copy came out a little darker. So if you guys could take a second and set up your statements and reasons. And we're told we have triangle ABC, and then we have a straight, we know these two lines are parallel. Okay, I'm just going to extend that a little bit. Okay, so this is a proof proving that all the angles in a triangle add up to 180. So our first step, we were given this. Remember, our given, what we actually want to prove, and we would tell you this, is that the measure of angle 2 plus the measure of angle, so here's 2, 4, and 5, is 180. Okay? So what we're going to have to do is sort of think of a plan for that. What we're going to start with is something we know on the top here. These 3 angles together should add up to measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. And we know that because supplementary, a linear pair. That's so weird. Why did I do that? Oh, there we go. A linear pair have to be supplementary angles, right? They all have to add up to 180, okay? So again, this is not something we would expect you guys to know off the top of your head. We just sort of want to talk you through it so that you get that idea. Now, this is a little bit neat, guys. Do you guys see how angle 1 and angle 4 are inside the parallel lines if this is a transversal? So I want to write a little note here. Angle 1 is congruent to angle 4. We also know, though, I'm going to use a different color, that angle 5 down here is congruent to angle 3. Why is that true? These are inside parallel lines on opposite side. So these angles, since we have parallel lines, so you can sort of write, let me show you guys a trick for this. We can say that two parallel lines imply alternate interior angles are congruent. Okay? So one trick too when you're doing proofs, do you see how I want to use the same reason for number 5? Because both 1 and 4 and 3 and 5 are alternate interior. I'm going to do this little mark. It just means you're continuing on the proof. Now look what happens, guys, when I do this. Okay, do you remember what we started with? We want to show this. We have this. So what I'm going to do is instead of putting an angle 1 here, you guys see how this is angle 1? Different color, sorry about that. This is angle 1 right here. Instead of putting angle 1 in, I'm going to put an angle 4. So let me actually do the measure of angle 1 plus the measure of angle 2. Don't write this yet, guys. Measure of angle 3 is 180. Now, if we use substitution, instead of putting in angle 1, I know angle 1 is also equal to angle 4. And then I know the same thing is true for angle 3. Instead of putting angle 3 in down here, I could put in, here's angle 3, I could put in angle 5. So now look back, that's a bad 5, sorry guys. Now look back at our statement, my dears. We have 4, 2, and 5. If I look back at my picture, do you guys see how 4, 2, and 5 are all the angles in a triangle? So that was just substitution. I just substituted in what we know is congruent, and that's what we wanted to prove. Okay? So great job being focused. You guys have a homework assignment on page 6, and we're actually going to ask you to change something really quick in your notes. If you could please definitely try 1, 2, 3, and 4. This is a review of all those kind of angles that we've talked about before. Alternate interior, alternate exterior, right? But we're going to actually ask you guys to change question 5. Erase the given and put L is parallel to M. And then we want you guys to show 4 is congruent to 6. And this is really similar to the proofs that we did before. So just a reminder, you want to do your statements and reasons, right? Okay. Have a super day, all stars, and please be in touch if we can help at all. Thanks for your hard work. Bye.